Dear students, now we are starting with the definition of arithmetic progression. Arithmetic progression. To understand arithmetic progression, we are taking some examples of sequences. Some sequences. First sequence is here 100, 70, 40, 10 and so on. Okay, here for every sequence write the next three terms. Okay, so in this sequence, first of all we have to find out first term means T1, then second term means T2, third term means T3 and so on. Then we have to find out the number which is added to the previous term. Okay, so in this sequence T1 is equal to 100. T1 is equal to 100. Then T2 is equal to 70. And how it will come? Here first term means T1 means 100 plus minus 30 is equal to 70. 100 plus minus 30 means 100 minus 30 is equal to 70. So 100 means first term means T1 plus minus 30. Okay, now next term, third term means T3 is equal to 40. And how it will come? Here the previous term means 70 plus minus 30 is equal to 70 plus minus 30 means 70 minus 30 is equal to 40. So 70 means second term means, that means T2 plus minus 30. Now T4 fourth term is equal to 10. And how it will come? Here the previous term means 40 plus minus 30 is equal to 40 minus 30 is equal to 10. So 40 means the previous term means T3 plus minus 30. Got it? So here a particular number, that means minus 30 is added to the previous term. Okay, to get or obtained next term. So now we can easily find out next two terms. Let us see how. Here T5 is equal to T3 plus minus 30. Here previous term means T4 plus minus 30 is equal to, here T4 fourth term T4 is 10 plus minus 30 is equal to 10 plus minus 30. So 10 minus 30, here positive and negative means different sign. So if there are different signs, there is subtraction, means here bigger number 30 minus smaller number 10, means 30 minus 10 is 20, and sign of bigger number, here bigger number is 30 and its sign is minus, so here minus 20. That is the next term, means fifth term, t5 minus 20. So here which number is added? Minus 30. Okay. So now next term, sixth term, that means t6 is equal to the previous term, means t5 plus minus 30 is equal to t5 is minus 20. t5 is minus 20 plus minus 30 is equal to minus 20 plus minus 30 is equal to, now here minus 20 minus 20, that means the same sign. So if there are the same signs, there is addition. So here 20 plus 30 is 50 and the sign is the same, means minus. So minus 20 minus 30 is equal to minus 50. So the sixth term of this sequence, that means t6 is equal to minus 50. Okay, so here also number, a particular number is added, that is minus 30. Okay, so in this way we have found next two terms, that means t5 is equal to minus 20 and t6 is equal to minus 50. Okay, now next sequence, second, minus 7 minus 4 minus 1 2 and so on. Let us see in this sequence. Here in this sequence, t1, here t1 means first term is equal to minus 7 here. Now t2, that means second term, is equal to minus 4, and how it will come? Minus 4 is equal to, here the previous term t1 is equal to minus 7, here minus 7 plus 3, minus 7 plus 3 is equal to minus 4. Why? Here the signs are different, so if there are different sign, there is subtraction. So here bigger number is 7, smaller number is 3, so 7 minus 3 is 4, and sign of bigger number, here bigger number is 7 and its sign is minus, so here minus 4. Got it? So here minus 7 plus 3 is equal to minus 4. That means minus 7 means t1, first term t1 plus 3. That means here number added is plus 3. Okay, now next term is t3 is equal to, here minus 1, t3 is minus 1 is equal to, the previous term means minus 4 plus 3, here also different signs, so subtraction. 4 minus 3 is 1 and sign of bigger number is 4, so its sign minus is for the answer. So here minus 4 plus 3 is equal to minus 1. That means minus 4 means the previous term, that is t2 plus 3. that means here the number added is plus 3. Now next term, fourth term, that is T4 is equal to 2. And how it will come? The previous term means minus 1 plus 3 is equal to, yeah, also different sign, so subtraction. So 3 minus 1 is equal to 2, and sign of bigger number is 3, so its sign is plus, so here plus 2. So here minus 1 means previous term, that is T3 plus 3. Okay, so here also number added is plus 3. Now we have to find next two terms of the sequence, that is fifth term means T5 is equal to, the previous term means T4 plus 3 is equal to, here T4 is 2 plus 3, 2 plus 3 is 5, 2 plus 3 is 5. So here also number added is plus 3. Now we have to find out next term, that is T6, sixth term of the sequence. So T6 is equal to previous term means T5 plus 3. So here T5 is 5 plus 3 is equal to, 5 plus 3 is 8. Okay, so here also number added is plus 3. So in this way we have found out next two terms of this sequence, that is T5 is 5 and T6 is 8 here. Okay, now we have to see next sequence, that is, I am writing here third sequence, 4 4 4 so on. Let us see in this sequence, first term means T1 is equal to 4, then second term means T2 is equal to also 4, and how it will come? The previous term means 4 plus 0 is equal to 4, that means previous term means T1 plus 0. That means here the number added is plus 0. Number added is 0. Now next term, third term, that means T3 is equal to also 4, and how it will come? The previous term means 4 plus 0 is equal to the previous term, that is T2 plus 0. So here also number added is plus 0. Now we have to find out next two terms of this sequence, that is T4 and T6. So T4 is equal to the previous term, that means T3 plus 0 is equal to, T3 is 4 plus 0 is equal to also 4, and the next term, fifth term, that is T5 is equal to also the previous term, that is T4 plus 0 is equal to, T4 is 4 plus 0 is equal to also 4. So here the number added is 0 and T4 is 4 and T5 is also 4. Okay, so here we have find out next two terms of these three sequences. Here we observe that in each sequence, means sequence first, second and third, in each sequence every term is obtained by adding, every term is obtained by adding a particular number. Okay, you can see here every term is obtained by adding a particular number in the previous term. Okay, here that means you can see here the difference, here the difference between two consecutive terms, the difference between two consecutive terms is constant. Means there is no change in the difference. That means the difference between two consecutive terms of the sequence is constant. That means you can see here the difference in example 1, means first sequence, the difference is here negative 30. Okay, that means the difference is negative. Here in second example or second sequence, you can see that the difference between two consecutive terms is positive, means plus 3. Okay, and here in the third sequence you can see that the difference is 0, the difference is 0 here. So here I am telling you what mean by arithmetic progression, means AP. In the given sequence, if the difference between two consecutive terms, in the given sequence, the difference between, if the difference between two consecutive terms is constant, then the sequence is called arithmetic progression. If the difference between two consecutive terms is constant, then the sequence is called AP. AP means arithmetic progression. And here the difference means D is the common difference. And here I am telling you the common difference is generally denoted by letter D. Here common difference D, let us see here, D is equal to, means common difference is equal to the difference between two consecutive terms, that means Tn plus 1 minus Tn. D is equal to Tn plus 1 minus Tn. Okay, and if in an AP first term is denoted by A, first term, if first term of an AP is A and common difference is D, then the first term, then the first term means T1 is equal to A. Why? First term of an AP is A, so for T1 means first term is A, then second term, that is T2, is equal to first term means A plus common difference means D. Then here also T3 is equal to T2 plus D is equal to T2 means A plus D is equal to A plus D 2D. D plus D 2D. So we can write here AP having first term as A and common difference D. So the AP is A means first term, then second term A plus D, then third term A plus 2D, and the fourth term is also A plus 3D. Then next term is A plus 4D, then the next term is A plus 5D, and so on. So in this way we can write the AP also. Okay, got it? Now here I am showing one example how to solve the examples of practice set 3.1, or I am starting practice set 3.1 here. Let us see practice set 3.1. Practice set 3.1. First example is first question here. First question is, which of the following sequences are AP? AP means arithmetic progression. If they are AP, find the common difference. Find the common difference here. So first example of first question is here. First example, 2, 4, 6, 8, and so on. Here in this sequence, first of all we have to write first term, second term, third term, fourth term. Then we have to find the common difference between any two consecutive terms. Okay, so here in this sequence, here T1 is equal to 2, then t2 is equal to 4, then t3 is equal to 6, then t4 is equal to 8. Okay, so now we have to find out the common difference between them. Okay, so here t2 minus t1 is equal to, yeah, common difference between any two consecutive terms, that is t2 minus t1 is equal to t2 is 4 minus t1, t1 is 2, so 4 minus 2 is 2. Okay, now next t3 minus t2, t3 minus t2 is equal to t3 is 6 minus t2 is 4, so 6 minus 4 is 2 also. Now next t4 minus t3 minus t3 is equal to t4 is 8 minus t3 is 6, so see 8 minus 6 is equal to 2 also. Okay, so here we can see that the difference between any two consecutive terms is 2, that means constant. Okay, so here so the difference between any two consecutive terms, the difference between any two consecutive terms is constant. So it is an AP, or so this sequence is an AP. And now we have to find out also the common difference. Yeah, this sequence is an AP with common difference is, here you can see the common difference between any two consecutive terms is here 2. So this sequence is an AP with common difference is 2. Okay, so in this way we can write the answer of each example. Got it? Now second example, here are the fractions also. So second example, 2 5/2, 3 7/2, and so on. So first of all we have to identify first term, second term, third term, fourth term, that means T1, T2, T3, T4 in this sequence. So in this sequence T1 is equal to here 2, then T2 is equal to 5 upon 2, then T3 is equal to 3, T3 is equal to, next term is 3, then T4 is equal to 7 upon 2. Okay, now we have to find out common difference between any two consecutive terms. Okay, so here T2 minus T1 is equal to, T2 is 5 upon 2 minus T1 is 2. So here five upon 2 minus 2 upon 1. Now here denominators are different, so cross multiplication. So 5 ones are 5 minus 2 twos are 4 upon 2 ones are 2. So here 5 minus 4 is 1 upon 2. So T2 minus T1 is equal to 1 upon 2. Got it? Now next difference, that is T3 minus T2 is equal to T3 is here, T3 is 3. Okay, so here 3 minus T2 is 5 upon 2. So here 3 means 3 upon 1 minus 5 upon 2. Here also the denominators are different, so we have to do cross multiplication. So 3 twos are 6 minus 5 ones are 5 here upon 2 ones are 2. So 6 minus 5 is 1 upon 2. So here also the difference between T3 and T2 is 1 upon 2. Now next means T4 minus T3 is equal to, T4 is here, T4 is 7 upon 2, T4 is 7 upon 2 minus T3 is here 3. So here 7 upon 2 minus 3 means 3 upon 1. Okay, so now here denominators are different, so once again cross multiplication. So 7 ones are 7 minus 3 twos are 6 upon 2 ones are 2. So here 7 minus 6 is 1 upon 2. Okay, so here you can see the common difference between any two consecutive terms is 1 upon 2 also. So that means it is constant. So we can say that this sequence is also an AP with common difference 1 upon 2. Okay, so here, so the difference between any two consecutive terms is constant. So here the difference between any two consecutive terms is constant. Okay. So this sequence this sequence is an AP, means arithmetic progression, with common difference is, here you can see the common difference is here 1/2, with common difference is 1/2. Okay, so in this way we have solved second example of question 1. Okay, now example number 3. Here all the examples are different from any other except example number 8. So I am showing you here example number 1, 2, then 3, 4, then I am showing you example number 1, 2, then 4, 5, 6, 7. Okay, the remaining examples means example number 3 and example number 8, you have to solve with your own. Okay, so now we are taking example number 4. Example number 4. 0.3, 0.33 and next is 0.333 and so on. Okay, so first of all we have to write here first term, second term, third term, that means T1, T2 and T3. Okay, so in this sequence first term, that is T1, is equal to 0.3, then T2 is equal to second term 0.33 and third term, that is T3, is equal to here 0.333. Okay, now we have to find out the difference between any two consecutive terms, that is first of all T2 minus T1 is equal to, here T2 is 0.33 minus T1 is 0.3 is equal to, here we have to find out the difference. So here let us see here 0.33 minus 0.3 is equal to, here 0 also, so here 3 and 3 minus 3 is 0, here is point, and 0 minus 0 is 0, so the answer is 0.03. so here T2 minus T1 is equal to 0.33 minus 0.3 is equal to 0.03. Okay, so here now 0.33 minus 0.3 is equal to 0.03. Now next difference, that is T3 minus T2 is equal to T3 is, let us see here, T3 is 0.333. So T3 is 0.333 minus T2 is 0.33. Here T2 means 0.33 is equal to, here I am doing subtraction, 0.333 minus 0.33, here 0, we can take 0 here, so 3 minus 0 is 3, then 3 minus 3 is equal to 0 here, then 3 minus 3 also here 0, here is point, and 0 minus 0 is 0. So here 0.333 minus 0.33 is equal to 0.003. So here T3 minus T2 is equal to 0.333 minus 0.33 is equal to, here let us see the answer, 0.003. Here let us see the difference. Here is the difference is 0.03, and here the difference is 0.003. That means the difference between any two consecutive terms is not constant. Why? Here the difference is different. Here is T2 minus T1 is 0.03 and T3 minus T2 is equal to 0.003. So the difference between any two consecutive terms is not constant. So here I am writing, so the difference, so the difference between any two consecutive, the difference between any two consecutive terms is not constant, is not constant. The difference between any two consecutive terms is not constant here. So this sequence, is not an AP, means arithmetic progression. So here once again I am telling you, in this sequence T1, T2 and T3, then difference between any two consecutive terms, that means T2 minus T1 is equal to 0.33 minus 0.3 is equal to 0.03. Let us see here the difference between them. Then next difference means T3 minus T2 is equal to 0.333 minus 0.33 is equal to 0.003. Let us see here the difference between them. So you can see that the difference between any two consecutive terms is not constant here. Okay, you can see that the difference between any two consecutive terms is not constant here. So this sequence is not an AP. AP means arithmetic progression. That means this sequence is not an arithmetic progression. Okay, so in this way we have solved our fourth example of question 1. The next example we are solving in next lecture. Okay, so now we are stopping here. Okay, so bye students.